Yes, welcome back. So now we are continuing with a topic on gradient of a straight line. So we said the gradient of a straight line is actually the steepness or the slopeness of that line, either upward or downwards. So that is what we basically looked at. And then we look at the elements of that, which was m. So m is actually the change in y values over the change in x values. So we saw that we have positive and then negative word gradient, and then we can even have a zero gradient. So that's what we looked at in the introductory video for the gradient of a straight line. Now let's go a bit deeper. So here we are saying that finding the gradient of a straight line on a graph. We are still talking about graph. So often the gradient of a straight line is needed on a graph. It's a basic element. Now the gradient must have a sign or size. So we looked at that introductory. We had a glimpse of that. So we said that if it's drawn from the bottom to the right side of the graph or of the body, that is what a positive gradient. And then when it's drawn from the left side, from the top down, we have the negative gradient. So this is basically what the sign. Then we talk about what the size. The size is simply the magnitude. What's the value of m that we can actually attain? So, and this is of the form gradient is equal to the vertical distance over horizontal distance, which we have said that is the change in the y value over the change in x values. Now the sign shows direction of the slope. So an up slope, which is drawn in this way, has the positive gradient, and then the other one of the negative gradient. Now there are some steps to follow. I have actually we have actually had a glimpse of that, but let's see how we can do this in practice. Right now we are saying that for the first point is to mark points on the line. So points on the line, this 1 point and this another point. So probably this is A and then this is B. Right, now you mark these 2 points and then you draw a line to pass through these points, like we said in the introductory video. Right, and then when you draw that, we can actually get something of the form, a basic property, a special property in math called what? The right angled triangle. So when we have this straight line, we have drawn them. If you want to check, you can do this. This is the dashes that we were talking about. We draw them here to 1 point and then draw them up, right? So it's like from here, this A, B point, A point. So a line here, and where we can actually go up to meet B. So this is it. Now after doing this, you realize that we are getting a special property in geometry or mensuration, which is called a right angle triangle. So don't worry, we'll get the mensuration, right? So that we get there soon. I think it will be the next topic after this, right? So this is what we are talking about. So when we get this, then we see that the y values will be here. That's the two values, right? When I say two values, we have x2 and then y2, because we started from here and we are ending here. So where the line starts is the 1 values. Where the line or the points start from, you draw the line from, is the 1 values. And then where we end or we get to is the 2 values. This is very important. When you get to the calculation, I don't want a situation whereby I put x here minus x2 minus xy. Then you'll be wondering, why did I put the x2 and not why the x1? So that's what we are saying. So it depends on the type, the sign, or yes, the sign of that magnitude that we are calculating. Are we calculating for positive 1? You have to know that. Are we calculating for negative 1? You have to know that. So that is what it means. Now we go on to see point 2, where is it? Work out the vertical distance and horizontal distance between the 2 points. Choose a point which will make the calculation easy. Use the grade lines to work out the distances. So it means that for a gradient of a line, we may have point A, point B, and point C. So what we are saying basically is you could choose any of the points, right? Because the gradient is the same along the line. That is what it means. In effect, the gradients along the line or straight line is the same. So if there were, let's say, point C here around this point, I could get the points here and this one to calculate. I could even probably choose point C and point A. Instead of point A and B, I could choose A and C and I'll get it, or B and C and I'll get it. So that's what it means. Now, basically based on the point, sometimes the point may be involving negative values, negative coordinates. So this is what they are talking about. That's the actual, the essence of what we mean here. So it's nothing, anything difficult. Right. So now let's move on. We are saying that always check that the sign of the gradient makes sense. Remember, an up slope has a positive gradient, and then down slope has a negative sign. This is what is drawn. So we see here, what I was probably finding difficult to explain to you is the upward, which is, this one is a positive, and then this is horizontal. You can say it is neutral gradient, and then this side is what? So assuming this is a graph that we have, right? A graph here, and then we have this thing drawn here. So it means that this was drawn from here to this point. So this makes it a positive gradient. So you see that the lines starts from here, the bottom, right? Not necessarily from the origin, right? You could start from here and go on. Well, the essence is that it's moving from the left side upward. That is what it means. And then for here, it's moving from, let's say we have this in here, right? I could actually even draw it here just to meet this point, right? And know that this line was drawn from the top coming down. So this makes it negative gradient. So this is basically what we are talking about. And for horizontals, the horizontal one, which is called the zero gradient, you can actually get a line drawn with the provided coordinates, and we get a straight line. It is possible, right? So you could get a straight line like this, and you could also get something like straight like this. A line which is straight like this is possible, right? So in practice, we will see these things. So you stay tuned. Now, I think I have some 3 minutes left. Let's look at some calculations involving numbers. Now, first of all, look at this graph, right? This is the graph, and this is the question that we have been given. So look at this critically. Now, what we see, we have two straight lines. We have A from here upward, this is A, and then we have B, 3. So for starters, we can say that A is a positive gradient. A is a positive gradient, and then we have B, a negative gradient. Now, the lines that were drawn to get the right angle triangle. For A, we see that the dashes from here, it was marked to that point and then marked upward. You see the points, giving the gradients or giving the coordinates, right? So from here, dashes to meet it. And the moment they meet, it forms a right angle triangle. This is it. Now, when you take B, look at B, from the top down, and then see the lines, the dashes, right here, to form the right angle triangle. So this is what we just read. Now, let's go back to the question. The question is saying that find the gradients of the straight line graphs in Fig 6.8. So this is what we are talking about. Right. Now, first of all, you know how to get the coordinate of a line. So for this one, we have this, you can, from the graph, you can get it. And then for the B also, you can get it. Right. So I think I'm running out of time, but I can just pause the video, and then with the formula that we derive, you can put it into it. So the gradient of a line, we have the vertical distance over horizontal distance, 9 minus 1, and then 4 minus 0. This point was actually getting from the lines, and then the same thing for B. So check it, and then you understand, you appreciate what is done. So I think the next one, I have to look for example and then do this actually. So I will see you in the next one. Stay blessed. Ciao for now.